Here's another example from assignment 1, number 1, for finding the equation of a tangent line to a graph of a quadratic function. So the first thing you want to do is to find the function value at the given point. So this is to find the slope of the tangent at 3. So first we want to find the y value at 3 by substituting in 3 into the function and simplifying. Now I would show out all the steps here if I were doing my own work, but the answer to this comes out to be 4. This is 9. When you do 3 squared, you get 9. Negative 1/3 makes that negative 3, plus 12 is 9, minus 5 is 4. So then we want to find f prime at 3, which means the slope of the tangent. And to find that, we use the formula that involves the limit as x approaches 3, because we're finding the slope of the tangent at 3, of f of x, which is the function, negative 1/3 x squared plus 4x minus 5. That's f of x, and then we need to subtract f of c, and f of c is f of 3, which is 4. And then we need to divide all that by x minus c, which is x minus 3. So then this becomes the limit as x approaches 3 of negative 1/3 x squared plus 4x minus 9 over x minus 3. Now you might be able to figure out how to factor with this fraction here, but I would recommend multiplying top and bottom of this expression by negative 3 over negative 3, so that this first term ends up being x squared. That will make the factoring much more manageable and easier to figure out. So limit as x approaches 3 is x squared minus 12x plus 27 over x minus 3. Now you should stop and try and finish the problem on your own if you just needed that hint on how to clean that up. But to continue, the factors of x squared minus 12x minus 27 are x minus 9 and x minus 3. Oops, I forgot the negative 3 down here. Hopefully you didn't stop before you figured that out. So then the x minus 3's cancel, and when you substitute in 3, you get 3 minus 9 is negative 6 over negative 3, which is 2. So that means that f prime at 3 is equal to 2. And we already know that f of 3 is equal to 4. That's what we did up here. So this means that for the line that we're looking for, we know that the slope is 2 and a point on the line is 3, 4. So then if you use the point slope formula, you get y minus 4 equals 2 times x minus 3, which is y minus 4 is equal to 2x minus 6, or y is equal to 2x minus 2. Alright, so next we want to graph the parabola, and I'm going to do that first by just finding the vertex, and then second by completing the square. So if f of x is equal to negative 1/3 x squared plus 4x minus 5, then you can get the x value of the vertex by doing the opposite of b over 2 times the a value. And simplify that. You get negative 4 divided by negative 2/3, which is negative 4 over 1 times 3 over negative 2, which is negative 12 over negative 2, or 6. That means that the vertex is at x equals 6, and then to find the y value that goes with that, you need to substitute in 6 into the function. And I know that you can all do that. When you do the work for it, it comes out to be 7 by substituting 6 in and doing 6 squared, which is 36. Negative 1/3 times 36 is negative 12. 4 times 6 is 24, so 24 minus 12 is 12, minus 5 is 7. So now I know that the vertex is at 6, 7, and you could start organizing some information in a table. I would recommend putting the vertex in the middle of a table, and then pick whatever x values you want surrounding it. So there's 6, 7. I would definitely substitute in 0, and when you substitute in 0, you can just figure out that it's 0, negative 5. By making x 0, you can see the value comes out to be negative 5. And we also know that when you substitute in 3, you get 4. So we figured that out over here when we found f of 3. So if we know that 6, 7 is the vertex, and we know that 0, negative 5 is a point, and we know it's a parabola, that means that there has to be a matching point over here the same distance away. So if this is over 6, then over 6 more to 12 will be down at negative 5. So that means that I know that there's a point at 12, negative 5, and I don't have to do the math of figuring that out because I know can use the symmetry. And then at 9, there must also be a 4 because of the symmetry with the 3, 4. So over 9 and up 4, and then over 3 and up 4 can be on there. And so that's enough points to graph the parabola. So Alright, so there's the parabola, and now we want to graph the tangent line. And I would highly recommend just going to the answer, your equation of the tangent line, y equals 2x minus 2, and kind of ignore the parabola, plot points on that line, and I'm going backwards just to help me draw the line on the computer here. But you'd want to start here and then head over here with a slope of 2. And you can tell if you get it right because it will just brush the point at the point of tangency, and we'll just brush the parabola at the point of tangency. Now here my sketch is just a little bit off and it looks like it's touching right there, but it's hard to draw on this computer program here, so you'll just have to trust me that I think our work is accurate. You can check it on your own. So there you go. It should be just tangent right there with everything we're drawn perfectly right. Alright, so next I'm going to show you a way to complete the square on this function to graph it, and I'm going to rewrite it here with a y variable. I think that's just a little bit friendlier to work with. Negative 1/3 x squared plus 4x minus 5. And this negative 1/3 makes the problem a bit trickier than what we did in class. There's a few different ways that you can deal with it. I'm going to multiply both sides of the equation by -3. And as long as you do it to both sides, then you're not breaking any rules. And so by doing that, it'll affect these other terms, but it won't make completing the square any harder. So this will be -3y is equal to x squared, which is what we wanted there, minus 12x plus 15. And then you can leave the 15 here and just kind of ignore it, or you can move the 15 over to this side to just get it out of the way, so that when you're completing the square, you're just working with the x squared minus 12x. Now we want to add something to this equation, and then we want to subtract something so that we don't end up actually changing the value. So whatever I put in this blank, I'm going to also subtract it right here because I have to compensate for it. Now to figure out what goes there, there's a shortcut for it, but the idea is that you know that the factors that you're looking for have to combine to -12x. So you are looking for factors. You want these to be exactly the same. So x, and if they're going to be the same, then these have to be the same. So they have to combine to -12 and be the exact same thing. So -12 divided by 2 gives me -6, and then the product of these is what goes in the blank. So to figure out what goes in the blank, you just take half of -12 to give you the -6, and then you square it to get the 36. So 36 goes in the blank, and then we need to subtract 36. So there's the subtract 36, and when this is in factored form, it's x minus 6 and x minus 6. And now that's the perfect square because they're both the same. So just now all we have to do is clean this up, get it back to y equals form. So it's x minus 6 squared minus 36, and then -3y is x minus 6 squared, and -36 plus 15 is 21, -21, and then we need to divide both sides by -3, and we get y equals -1/3 times the quantity x minus 6 squared plus 7. And then you can see the vertex in this form is at +6, +7, which is the same that we got up here. And then finding more points on the parabola, you could do that a variety of different ways. You could make a parent table for x and x squared with -2, -1, 0, 1, 2. And that would be 4, 1, 0, 1, 4. And then when you do the table for it, the headings of the new table would be x is +6 and -1/3 y plus 7. And you could take all of these and add 6 to these and do -1/3 y plus 7 to find these, and that would work. You're not going to get such friendly y values here, so you might prefer, once you get the vertex, to just plot a few other points like we did here. So once you know the vertex is 6, 7, you could substitute in 0 to find a point, and then that would give you 0, 12, and you already know 3, 4, and so you can find 9, 4. But knowing how to find the vertex of a parabola by changing it to vertex form by completing the square is an important skill. You should know how to do that.